Hey everyone, happy Thursday. It's Miss Ryan back again looking at the next part of this question. It's the same question stem from yesterday. So we had our rate in and our rate out for fish entering and leaving a lake. And part C is a tough question. It's the candidates test. It's asking for at what time for 0 to 8, from time 0 to 8 is the greatest number of fish in the lake, and to justify your answer. This question is a little weird because it doesn't tell you how many fish are in the lake at time 0. So all you know is the rate they're entering and the rate they're leaving, but you never knew how many were there to begin with. So we are going to start with our chart, and we know that, oh, I'm supposed to remind you, if you want to pause and try this on your own, go ahead and do that right now. We're looking for a maximum, right? The greatest number of fish, and a maximum can happen at an endpoint or a critical point. So we know that 0 and 8 are going to be in our chart because those are the endpoints, but we also need to find the critical point. And the function we're going to be using, I'm going to say a, let me use x here. And we have that same idea from yesterday that if we know the rate that fish are entering, then the antiderivative is going to give me the actual amount that have entered. And I'm going to go 0 to time x. X is my independent variable. And then the rate that they're leaving is L of t. I'm going to actually erase that first dt. There we go. Okay. And you can have two separate integrals for this, but for typing it in the calculator, it's going to be easier to just have one. So for both of these functions, since they were the rate fish are entering, we use the antiderivative to get the amount that's entering, and the rate that they're leaving, the antiderivative will give us the amount that's leaving. And we saw some of that yesterday. So that's the function for, it's not the amount of fish in the lake because, like I said, we don't know the amount that's there in the beginning, but it is, let's see how they phrased it on the rubric. They said, they labeled it as the change in the number of fish. That makes sense. The change in the number of fish, because you know the amount entering and the amount leaving, so that would be the change in the number of fish in the lake. So let's start with still finding that critical point. So our endpoints are in the chart, and then we know we're going to use this a of x will be a of t over here function to find the change in the number of fish in the lake. And we want the critical point. So the critical point is where the derivative is 0. So where is a prime equal to 0? So if we take the derivative is going to be, the derivative of a is a prime, and then the derivative and this integral sign, the antiderivative, cancel out, and we would have e of x minus L of x. So that's our derivative, and for the critical point, we want to know where is the derivative equal to 0, and that's the same thing if I move that L of x over. It's the same thing as finding where are they equal to each other. So that's going to be done on the calculator. I'm going to go over here to this emulator, and you can pause to catch up with me here. I have the rate that the fish are entering, the rate that they're leaving. I graphed both of those functions, and the window, I did 0 to 8 because in the question it said from time 0 to 8. And then the y's, I couldn't see the intersection, so I had to change it to 0 to 20. And your graph would look like this, and you can do second trace number 5, enter, enter, enter. And we get that intersection of 6.2035644. So that is our critical point. And that's going to be the last number in the chart for the candidates test. 6.20356, I think it's 49. Because it's not the end of the problem yet, we don't want to round. So the last part is plugging that into the function. And I'm going to rewrite our function here. So we had a of x, and then from 0 to x, e of t minus L of t. And that's bringing us from the rate of change that the fish are entering and leaving to just the actual amount of fish that are entering and leaving. This is going to be a great opportunity to use our shortcuts on the calculator. So if I start with plugging in the 0, actually, I'm not going to type that in because we know if we were to put a 0 up here, then that's just going to be 0. So the next one I'll do is 8. So I'm plugging in 8, and I'm going to go to my calculator, and I'm going to do math 9, 0 to 8. And then instead of typing in those functions, I'm going to do alpha trace for my y1 minus alpha trace for my y2. And that's dx. And I get 80.9199. So I'm going to write that in my chart. And that was for when I plugged in the 8. So 80.9199, something like that. And then I wonder, oh yeah, okay, so I'm going to go up and grab that. Another shortcut. And then instead of time 8, I'm going to type in 6.2035649. And I get 135.01492 basically. So I have 135.01492. All right, so almost done. For what time is the greatest number of fish in the lake? It's going to be at this time because they're not saying that there's 135 fish, but the amount of fish entering minus the amount of fish leaving is 135. So there's more entering than are leaving. And as compared to 0 and 8, that's true as well. So I would finish with a sentence. At what time is the greatest number of fish in the lake? So the question is actually just looking for the time. So we can say the time the greatest number of fish are in the lake is t equals, and you have to go to 3 decimal places here. So 6.203, 6.204 would also be okay if you're rounding. The first one is truncated. All right, so that is the ever challenging candidates test, and I will show you the rubric here. You can see they wrote the same function that we did. They found the derivative, they found the intersection, and they wanted to label that intersection capital C. And you can label it, if you want to do that, you can label it anything you want. And you can see that that's what they put in the chart instead of writing the number. That's up to you. You don't have to do that. I just wrote the number in the chart. But since they labeled it as C, they could use that afterwards. And you can see them plugging in the numbers just like we did and finishing with a sentence. So they gave you a point for setting the derivative to 0. That was just finding the critical point. They gave you a point for the answer, and that is the answer of 6.204 or 6.203. And then they gave you a point for the justification, and the justification is actually just the chart that you made. You didn't have to write anything else. All right, that is a tough question. Remember from yesterday, parts A and B were 2 points each. Even if you just got those 4 points on this question, that would be amazing and incredible. And for people that wanted to see that candidates chart again and try to follow along with that, I hope this was helpful. Clearly, I don't know how to stop this video.